Hey Chemistry, it's Mr. Fleming, and today we're going to do the Copper Cycle Lab. We will be focusing on chemical and physical changes, and we will have a formal lab write-up called a clear at the end of this assignment. So make sure you pay attention and watch as many times as you want.
Hey guys, I am all set up in my safety gear, my apron, my goggles, and I have my directions here. I am going to start with step 1 and 2, and you can read that along. So, first it says to measure approximately 0.1 gram of copper powder. So I'm gonna plug in my thing, turn it on. This is my scale. Why aren't we coming on? There we go. And you can see here, when we're using the scale, we wait for it to go to 0. This is my weigh boat. I don't want that in there. So I'm gonna hit tare, and it's gonna make that 0. And now I am going to use my scoopula to get 0.1 grams of copper. Look at that pretty copper, isn't that pretty? Oh, too much, too much. It's a very small amount, so let's see how that goes. Oh, perfect. Can you guys see that? It's such a pretty little amount. And I'm going to put that into a 250 ml beaker. Here it is. Get all of that in there. Okay, so whenever we're done, we want to cap our stuff and make sure it's good to go. And then we're going to go over here to the fume hood. This is the fume hood. And in the fume hood, it pulls air in. So none of the fumes we make are going to come out. Put this underneath it so you can see it. So here is 8 molar HNO3. That is nitric acid. That's pretty tough stuff. So that's why we're doing it in a fume hood. And we're gonna take this. Is that a good angle, Mr. Fleming?
Yeah, that's pretty good.
Okay, and we put it right on there, and you can see what's happening. There's bubbles. Let's see, is that better?
Yeah.
And can you see what's happening behind there?
That's perfect.
There is, the liquid seems to be turning blue, and if we keep watching, you'll see kind of a brown gas forming right on top of it. So we have to let this wait. We don't want to breathe in that brown gas. Can you guys see that in there? It's pretty amazing. And the blue, the liquid itself is turning blue, and we don't want to breathe in that brown gas. That is no bueno. So we're gonna let that sit here in the fume hood until the reaction is complete. And Mrs. Williams will come up and show you what to do next.
All right. Hi guys, Miss Williams here, ready to continue our experiment. So now that we have allowed the brown gas to remove itself from the system, I'm going to move on to step 4. Okay, so I'm going to safely grab my glass beaker and take it back to my station. So I want to make sure that I don't lose anything. I want to hold it nice and securely. All right, so we are now here, and I want to make sure my space is clear. And I want to make sure that I don't put it too close to the edge. So step 4 is add approximately 25 milliliters of water to the beaker. All right, and in order to do that, I don't want to just pour 25 milliliters of water into the beaker, because how am I going to measure that amount? So I want to use a graduated cylinder. We have here a 50 milliliter graduated cylinder that I want to use to measure my 25 milliliters of water. I'm going to get the deionized water here, which is just another fancy word of saying very purified. And I'm going to measure out 25 milliliters of water. So I'm going to slowly do this, and I'm going to get eye level so that I can ensure that I get the appropriate amount. So as I pour, or squeeze rather, and as you get closer to the actual amount, you want to start to slow down and just make sure that you get eye level. And you want your meniscus to be, the bottom of the meniscus should be at 25. So right now I'm a little below. I want to add just a little bit more so that my meniscus will be at 25. One more squirt and I should be good. All right, perfect. So I'm going to simply just add this to my solution here. All right, that's step 4. Now, step 5, using a graduated pipette, carefully measure 2 milliliters of concentrated sodium hydroxide, which is NaOH, okay? So my NaOH is here, and we have an 8 molar solution. You guys will figure out what that means a little later on. But this is our sodium hydroxide. So I slowly want to pour this into the beaker. So I'm going to take this off and use my pipette to measure about 2 milliliters. Okay, so these pipettes get about, this is a plastic pipette, and they get about 1 milliliter per squeeze. So I'm going to do this twice. All right, and that's 1 and 2. So you should now be seeing some precipitate forming, and precipitate is just kind of like a solid-like substance forming in the bottom of our beaker. All right, so it says observe our liquid. So we did that, and we have a very luminous blue color with that precipitate at the bottom, okay? All right, I don't want to move it too much because I don't want to disrupt the system. All right, and then next we want to place the beaker onto a hot plate and set the hot plate to medium. Stir with a glass rod while heating. Continue heating until a solid appears in the solution. This may take up to 10 minutes. So I've preset my hot plate to a medium temperature. I'm going to place my beaker directly to the hot plate, and I'm going to use this glass stirring rod to stir my solution. Okay, so as it heats, I'm just going to stir. And I'm looking for a solid substance to form, okay? So that precipitate was at the bottom of this beaker, but I want it to form a more crystalline structure solid, okay? So I'm gonna continue to stir, and it looks as though it is starting to form larger crystals as I stir. Also, I would like to indicate that there are pieces that look like black or brown pieces, or even maybe like a reddish color, that are at the bottom of my solution as well. Okay, and it is starting to solidify.
You can see how quickly the color is changing.
Yes. So we've gone from a luminescent blue to like a darker bluish with a little teal, almost greenish maybe. And it's consistently getting darker as we stir. And again, this may take up to 10 minutes. So we'll continue until I am satisfied with the amount of solid that is at the bottom of our beaker.
Just look right here where it's like popping up everywhere it gets hot. It, like,
Oh yeah,
pops
I see
up.
it popping up. That's a good, oh yes, are
Come
you
on,
recording
Miss
that?
Circle.
Oh my gosh, it's so cool.
Okay, and then I will give it a good stir. You ready? And so we're really starting to see the reaction taking place. But it's still a little too blue.
So moving right along to step 7, it says use beaker tongs to move the beaker from the hot plate to the lab table. Allow the beaker to cool before proceeding. So here I have my beaker tongs. I could have also used what we call hot hands to get this beaker off, but either way, it's just to avoid us getting burned, okay? So I'm gonna take it here, and as you can see, is no longer blue. It's a black solid substance at the bottom of this solution now. In the meantime, while you guys were waiting on your substance to solidify, you can prepare for step 8, which is to filter your product, okay? Filter your solution. So in order to filter, we have here a piece of filter paper, and you always want to use a funnel to filter your materials. So how do we get this piece of paper to fit in here? We want to make sure that we fold it accordingly so that it can fit and we don't lose product. So we'll start with folding it in half. Okay, and then we'll get another half. And because we have a large filter, or excuse me, a large funnel, this may work. If you would like, you can also do it one more time. Fold it over one more time. And now you should have a triangular shaped piece of filter paper that you will open up and insert into your funnel. Okay, it's not gonna be perfect, but as long as you know that when you pour your material in your solution into the funnel, it's not gonna lose any product. Okay, so you might have to fold it a little bit thick, and then you're gonna simply set it here on what we have is a ring stand, and this ring stand can hold our funnel, and we'll place a small 100 milliliter beaker to collect any of that solution from our product. And that's how you set up a filter with a funnel to filter product from a solution.
Welcome back, everybody. I am Dr. Mitchell, for those of you that I have not gotten the chance to meet yet. I'm going to pick up where Ms. Williams left off. So Ms. Williams took you through step 7, which got you set up for filtration. If we were in a classroom setting, this is what you would have done. You would have gotten through this filtering step and then left it overnight for your precipitate or your solid to dry. To expedite the process a little bit, I'm actually going to use a slightly different setup that you might have used either in AP Chem, or if you're going to take Chem 120 with me, where we're going to use vacuum filtration instead to collect our solid. So in this setup, what we have is, this is what's known as a vacuum flask. On the top, there's a rubber stopper And you'll notice that the rubber stopper is hollow so that we can fit what's called a Buchner funnel through it. We place the Buchner funnel on the top. And then to the inside of the Buchner funnel, we're gonna add this smaller piece of filter paper, and that's what's gonna collect our solid. Now, we don't have actual vacuum systems connected to our bench tops. And so you'll notice that at some of the sinks, there's this very weird adapter. This is what's gonna allow me to pull vacuum or air from the outside through this flask just by turning on the water. So when I turn on the water, there's vacuum being cooled here. To demonstrate that, I'll squirt and wet the filter paper with a little bit of water just to make sure that there's no solid that's going to go through. And you'll notice that liquid is in fact being pulled into the vacuum flask. So now I'm going to check my beaker to make sure that it's sufficiently cooled. Hot glass looks like cold glass, so you never want to just go and touch glass with your bare hands. Use the back of your hand, put it near the glass to see if you can feel any of the heat coming off of the glass. Chances are, if you can feel heat coming off, it's probably still too hot to touch. I don't feel anything, so I know it's safe enough for me to touch with my hands. Now, whenever it is that you are filtering a solid, the idea is to kind of swirl to get that solid suspended. Pour it into the funnel. So if you notice, our solution looked one way, but as it's coming through, our dark solution is now looking more translucent and clear, or colorless, as I like to say. So just a science terminology, translucent means see-through. When we refer to something as not having color or clear, we refer to it as colorless. All right, and so if we look at our beaker, we see that we still have some solids in there. I want to try and get as much of this out as possible. And so I'll take my water bottle and squirt the sides down with distilled water, trying to get as much of that solid down in the bottom as possible and off of the sides of the glass. I'll give it a good swirl just to try and get everything suspended. And then one last dump into our funnel, our Buchner funnel, so that that solid ends up with the rest of the solid that we made. And at this point, we're just gonna let it go through. We're gonna continue to pull vacuum on it to try and dry the solids as much as possible before continuing on with the next step.
Hey guys, Ms. Robinson again. While Dr. Mitchell was doing her filtering, I set up a gravimetric filtration. And so what you can see is I'm still getting my solid in here, and the clear filtrate is down below, but it's gonna take a lot longer for mine to be completed.
So we're checking the solid. I'm just kind of scraping down the side so that we'll be able to get everything out and access that filter paper that's now underneath what's called a filter cake.
It looks like a cake.
Ms. Williams here again. We are now moving on to step 9. Using a small spatula, gently scrape the solid from the paper into a 100 milliliter beaker. We're gonna adjust that just a bit and use a 250 milliliter beaker. And that's just so that we have a little bit more area to scrape, okay? So here's our product that we vacuum filtered, and we wanna scrape this into our beaker so that we can move forward with our experiment. All right, so I wanna be careful not to get the filter paper. So when I scrape, I wanna make sure, and I don't wanna touch it too much because I don't know what this is, or you don't know what it is, rather. So I'm gonna slightly, now that I have that, and in an ideal world, this would have been a lot drier. It would have dried overnight, and it would have been a lot more easy to scrape off. But overall, all right. So we have some nice product here that we have in our beaker. Looks nice and pretty.
Oh, that's so cool.
All right, moving right along to number 10. Measure out 15 milliliters of 1 molar of sulfuric acid, which is H2SO4, this substance here. Okay, it's 1 molar, so it's not gonna be as detrimental as if it were, let's say, 5 or 10 molar, but
Or the stuff in car battery acids.
right, exactly. Sulfuric acid, okay, so yes, it's not heavily concentrated, so it's going to be a lot more safe to manage and deal with. So, and in the ideal world, if we were in class, you would have already read all of these procedures, but I'm just reading them again as you go to model best practices, because even after you have read the entire procedure list, you still want to reread your procedures as you're going through to ensure that you do not make a mistake, all right? And that cuts down on your experimental error. All right, so again, measure 15 milliliters of 1 molar sulfuric acid, H2SO4. Slowly, while stirring, add the sulfuric acid to the 100 milliliter beaker, or in this case, the 250 milliliter beaker. As you add the acid, watch for any changes to the liquid and the solid, all right? So again, I want to measure out 15 milliliters of our liquid. So for accuracy purposes, I want to use, accuracy and precision purposes, I want to use a graduated cylinder, okay? So 15 milliliters, again, I want to keep that on a flat surface, and I want to get eye level so that when I measure out my 15 milliliters, I do not go over the amount, the recommended amount. So I'm gonna pour slowly. That's a little fast. All right, a little bit more.
What?
Oh, I got a little bit on the outside. If that would have went on the inside, that would have been perfect. So we're not in a perfect world, so we're gonna just keep it with what we have. It's at about 15.
I mean, that looks pretty darn good. Yeah. Okay.
All right. So, because this is acid and some did slide down the outside, I do want to wipe this. I don't want to just go and touch it because acids are still dangerous regardless of their concentration. All right. All right, so I have my 15 milliliters. I also have my glass stirring rod, and I'm going to pour slowly and stir simultaneously. And so we see So now you're gonna start to see some coloration. You see that the materials are starting to dissipate, the solid, and the precipitate is actually now looks like being dissolved possibly, or it could be doing some other things that we'll talk about as we get through this course. All right, and so what's happening? What is happening here? What happened to our product? Okay, product is now no longer a solid anymore. Just about. And I'll give this one final swirl just to make sure I got all my stuff off the side of the glass. All right.
So I'm back, Dr. Mitchell here. We're going to go through those last final steps of this copper cycle lab. So what we're going to want to do now that your dark precipitate has seemingly changed in appearance is we want to add a reagent known as zinc to it. Specifically, we want to add 0.1 grams of zinc. So coming back to our scale, we have a weigh boat. We want to remember to tare the scale again to make sure that that mass from the weigh boat is not being taken into account, and use our scapula to try and get that 0.1 grams of zinc in. So what are you noticing about the color? All right, so it's 0.1, it's supposed to be 0.1. We're a little bit in excess at 0.16 grams, but that is okay for our next step. So we'll take it, add it to our beaker where we use sulfuric acid, H2SO4. And again, I just want to stir as things are happening. So hopefully you made note of how the zinc appeared. And if not, the nice thing about videos, you can go back and see where if you were in the classroom, you were pretty much done. And so you can see bubbles coming off of where the solid is in this liquid solution. What phase is that product in if you're seeing bubbles? And so sometimes in chemistry, what you want to do is if you have solids that are sticking together and they're still reacting, you want to break it up a little bit. It'll help the reaction go a little bit faster. What are you noticing about the intensity of the liquid portion of the reaction as it's going compared to when you first started? noticing about the color of the solid that is on the bottom? Is it the same? Is it different? In case it's a little hard to see on the video, I will say it appears to be a little bit more of a reddish brown color now compared to what we started with, which was kind of silvery, metallic-y looking. Stir. As it goes on, the difference in colors is becoming much more apparent. Alright. So at this point, the amount of bubbles that I'm seeing is definitely slowed down a lot, and had we been together in the classroom, I would have asked you to probably add more zinc to make sure that the liquid portion of the reaction was completely colorless before continuing on. But, excuse me, for this particular one, I'm just gonna go ahead and filter my solid so that we can do a closer examination of the solid by itself. So again, right now I'm going to use the gravimetric filtration process that Ms. Robb had demonstrated earlier to isolate these solids. So again, swirling to try and suspend the liquids as much as possible, quick dump into the filter paper. And keeping in mind that these are skills that I have built in the course of my 10 years studying chemistry. It might not have looked as easy as that if you were doing it yourself. But when you get really good, you would also notice that there's very little solid left in my beaker as a result. I'm just gonna let that filter through, just so you could see the difference in the liquid that is significantly less intense in color compared to when we first started. And then once all of the filtrate goes through, we'll take a closer look at the solid that has resulted at the end of this cycle.
Okay, so here's our materials, and I'm so glad that I got to work with three of my favorite colleagues to make copper.
So we started with copper and we ended with copper. Let's take a look at it.
And that's a copper cycle lab.
And my goggles are fogging up because I have my mask on.
Stay socially distant.